Hi students, welcome. So here we are going to discuss JEE Advanced PYQ on the work energy power. In this question it has been given that the work done on a particle of mass m is given by this force. So look, this force is variable in the terms of the coordinate x and y, right? A being a constant of appropriate dimension when the particle is taken from the point a comma 0. So I have taken the diagram for this question. So the diagram looks like this, that this particle is moving from a comma 0 to the 0 comma a in a circular radius of a, right? So there is a circle of a radius and this particle is moving from this a comma 0 to 0 comma a on that path, and this is the force. Then we need to find out the work done due to this force. So now here we know one thing is that this force is variable. If the force is variable, then we know that the work done integration of F vector dot ds vector. This formula we are going to apply. Now the problem is that the force is given in the form of the x and y direction. So I will write down the force vector as F vector equals to Fx I cap plus Fy j cap. Alright, and the ds vector is the displacement vector. Now this particle is moving in the plane, so that's why it will have simultaneous displacement in x direction and y direction. So it means ds vector can be written down as dx I cap plus dy. So till this point we don't have any problem. Then I can write down the work done W as integration of F vector, which is Fx I cap plus Fy j cap, and dot product with dx I cap plus dy j cap. Alright. Now when I do this dot product, then I know that the I dot I is going to be 1 and the j dot j is going to be 1, others will become 0. So then the work done is integration of Fx dx, and now I'm just replacing this, I'm separating the integration. So Fx dx plus integration of Fy dy. Alright. Now here we know the Fx term, this is the Fx term and this is the Fy term, right? Okay, so then we can write down the work done. From here I'm starting to solve this question. So integration of Fx, which is x divided by under a x square plus y square to the power 3 by 2, right, multiplied by k. K is the constant I can take out from the integration. This is the Fx term. Look here, this part is the Fx term. Okay, so I have taken that in the Fx, and then the similarly there is y divided by x square plus y square to the power 3 by 2. So here we are going to get dx plus integration of Fy, which is y divided by x square plus y square to the power 3 by 2 multiplied by dy, and we are going from the coordinate a comma 0 to the 0 comma a. Alright, so it means the x coordinate is changing from a to 0, right, because we are going from a comma 0 to 0 comma a. So x coordinate is changing from a to 0 and the y coordinate is changing from 0 to a. Alright. Now the problem in this integration is that this integral of x is having the y term and the integration of y is having the x term. So I need to replace these x and y somehow. So for that I will use the equation of the path. We know that this particle is going to move in this circular path like this. Now the radius of this circle is a and the center of the circle is 0 comma 0. So you know, of course, the equation of the circle is x square plus y square equals to a square if the center is on the origin. So it means I can replace the x square plus y square with the a square. That may help us in the integration of the force, right? So W is k integration from a comma a to 0, and look here, I am having this term x square plus y square to the power 3 by 2. If I replace it with this a square, then the y term from the x integration will be gone, right? So that I am going to do, right? Okay, so then I will say that x dx, I'm not changing this, and this x square plus y square, this part I'm replacing with a square. Okay, so then it is a square to the power 3 by 2. Okay, so then it becomes a square to the power 3 by 2, then plus, and there is k common, I am putting k common, and then 0 to a, then we have y dy, and it becomes a square to the power 3 by 2. Okay, let us solve this. So then work done W is k, and then this is going to be x square divided by 2, right, x dx, and a square to the power 3 by 2, this part is going to be a square, and 3 by 2 will be cancelled out, so basically it will become a cube. I can take out, this is just the constant, and here as well I will have a cube. So from both of the integration I am taking out a cube. Okay, so then it becomes x square divided by 2, and the limit is a to 0, right? Okay, then that side we have plus y square divided by 2, and the limit is 0 to a. I know from here you can directly say work done will become 0, right? Why? Because this term is going to be negative and this term will be positive, so they will be equal and opposite, so they will be cancelled out, right? Okay, so here when I put the limit, so then 0 limit, upper limit becomes 0, and the lower limit becomes minus a square divided by 2, and then we had the a as upper limit in this, so then we'll get a square divided by 2 minus 0. So basically here these terms are cancelled out, so 0 multiplied by k divided by a cube becomes 0, so total work done will become 0. This is how we are going to reach on the answer of this question. These kind of question has appeared multiple times in the JEE Advanced, so that's why this concept is very important. Okay, if you want to watch other videos on the work energy path or the other topics, you can watch our channel. Thank you.